Welcome to Unleashing Machine Intelligence, the state of AI research. In this episode, we embark on a curated journey through 39 groundbreaking AI research papers from the arXiv preprint server's cs.AI category, all published in October 2025. Our exploration focuses on the latest advances in reasoning, collaboration, safety, and innovation, with an in-depth spotlight on the seminal work, Barbarians at the Gate. Whether you are a researcher, an enthusiast, or simply curious, this guided tour reveals key discoveries and insights shaping the future of artificial intelligence. In the past year, artificial intelligence systems have begun to autonomously invent algorithms that outperform the best human-devised solutions. Some of these AI models can rewrite their own algorithms overnight, achieving efficiencies that were previously unimaginable, slashing costs in half or increasing speed by a factor of 5. Imagine digital minds that not only solve puzzles of increasing complexity, but also adapt to rules they have never encountered before. As these systems are deployed to tackle global challenges in medicine, climate, law, and logistics, the AI revolution is no longer a distant vision. It is unfolding right before our eyes. This episode offers a guided tour of artificial intelligence's fastest-moving frontier. By examining 39 papers published in a single week, a vivid snapshot of progress in cs.AI is provided. These research efforts are actively reshaping the processes of discovery, decision-making, and the establishment of trust within the field. The primary focus today is on advances in reasoning, collaborative systems, and safety mechanisms. The objective is to reveal how the boundaries of knowledge are being shifted by AI, making these developments accessible and relevant for anyone intrigued by the future of intelligent systems. The field of cs.AI, computer science artificial intelligence, serves as the heart of computer science, where concepts from mathematics, neuroscience, linguistics, and engineering converge. It can be likened to a grand central station for interdisciplinary exchange, with ideas constantly arriving from diverse disciplines. Over the years, cs.AI has evolved from early rule-based systems to vast, data-driven neural networks and foundation models. These are not merely tools. They are reshaping economies, industries, and society itself. Think of AI as the ever-expanding, bustling heart of a city, driving innovation and connectivity. A central theme in current AI research is reasoning and planning at scale. Modern AI models now tackle complex, multi-step reasoning tasks, pushing the boundaries of what was once possible. Projects like Puzzleplex are constructing the ultimate benchmarks for reasoning, enabling these systems to be tested like chess grandmasters planning 100 moves ahead. Foundation models, large neural architectures capable of adapting, learning, and generalizing, enable broad and flexible problem-solving, allowing AI to address challenges across domains with unprecedented sophistication. Collaboration in AI is advancing rapidly, particularly through multi-agent systems in which artificial intelligences work together as coordinated teams. Notable work on belief-calibrated consensus mechanisms, such as by Zhang and collaborators, shows agents debating and sharing clues to reach agreement. Off-trajectory reasoning, explored by Kim and colleagues, enables agents to solve previously unseen problems by extrapolating from limited data. The analogy here is a team of detectives pooling evidence to uncover the truth, with consensus mechanisms ensuring that agents align on accurate answers even in uncertain environments. Safety, alignment, and neural-symbolic AI represent a critical frontier. Ensuring that AI systems remain trustworthy, especially under pressure, is an ongoing challenge. Sun and colleagues document how a model's refusal to execute harmful requests can suddenly fail, a phenomenon known as the refusal cliff. Patel's team investigates alignment failure points in Moloch's bargain. Meanwhile, neural-symbolic AI, as advanced by Lee and associates, merges logical reasoning with neural pattern recognition. This blend is likened to a jazz improviser collaborating with a classical composer, aiming for systems that are both flexible and transparent. The overarching goal is to ensure AI is safe, interpretable, and robust. Several key findings have emerged from the frontier of AI research. Cheng and colleagues demonstrated that AI can invent solutions surpassing those devised by human experts. Sun's work revealed the fragility of safety mechanisms, where a model's intention to refuse can vanish, exemplified by the refusal cliff. Wang and collaborators introduced generalist reasoning modules that substantially enhance multi-agent teamwork. Brown and Associates developed the Mathemagic benchmark, which prevents models from simply memorizing answers and ensures genuine understanding. Additionally, research on D2E shows that skills learned in simulation can be transferred to physical robots, bridging the gap between digital and real-world performance. A standout paper, Barbarians at the Gate, by Cheng and colleagues, investigates whether AI can not only automate but also invent within the domain of systems research. The motivation is to test AI's capacity for innovation in areas where small algorithmic improvements can yield significant economic and technical benefits. Their approach utilizes a closed-loop system in which AI generates candidate solutions, tests them via high-fidelity simulation or deployment, and iteratively refines its designs. The core platform, PenEvolve, is open source and adaptable, enabling broad algorithmic innovation across tasks such as cloud scheduling and SQL optimization. The analogy is a tireless inventor in a sandbox, persistently exploring new ideas. The results from Barbarians at the Gate are striking. AI-driven systems not only discovered solutions that were up to 5 times faster and 50% less costly than those devised by human experts, but also invented new algorithmic variants previously unknown. This level of creative exploration is enabled by reliable evaluators, which judge the effectiveness of candidate solutions at scale. The role of human researchers is shifting. From performing tedious search tasks to providing creative oversight, defining problems, and designing evaluators, many researchers reported increased job satisfaction as a result of this new mode of collaboration between humans and AI. However, significant challenges and implications accompany these advances. A key concern is ensuring that AI-generated solutions are understandable and transparent. Risks include overfitting to narrow benchmarks, unintended consequences upon deployment, and a potential loss of transparency. The culture of research is evolving as AI transitions from being merely a tool to acting as a peer collaborator. These shifts extend beyond computer science, affecting fields such as physics and chemistry. As Cheng and colleagues emphasize, AI is now actively driving and not just supporting the frontiers of systems research. Looking forward, the landscape of AI research can be envisioned as an ever-expanding city. Mechanistic interpretability, tools and methods that illuminate the inner workings of AI models will become as fundamental as debugging in software engineering. Dynamic and robust benchmarking practices will compel models to demonstrate genuine reasoning abilities rather than rote memorization. The fusion of neural and symbolic reasoning is projected to mature, yielding AI systems that are both flexible and precise, capable of improvisation as well as rule-based operation. Human-AI collaboration will continue to evolve, with AIs handling much of the exploratory and optimization work, while humans define goals, boundaries, and ethical standards. As agentic and embodied intelligence bridges the gap between simulation and reality, the prospects for revolutionizing fields such as robotics, logistics, and healthcare are immense. In conclusion, artificial intelligence is advancing rapidly, discovering, collaborating, and in certain domains, even out-innovating humans. Real challenges persist, particularly in the areas of safety, adaptability, and interpretability. However, the opportunities for meaningful human-AI synergy are significant. Those inspired by these scientific glimpses are encouraged to engage directly with the research, join scholarly communities, or initiate new projects. The next major breakthrough could emerge from any contributor, emphasizing the openness of this evolving frontier. The synthesis and review of this episode combined advanced AI tools and human expertise. Drafting and summarization were performed using GPT technology, specifically OpenAI's GPT 4.1. Text-to-speech synthesis was supported by OpenAI, while image generation utilized Google's platforms. A human expert reviewed and curated all content for accuracy, though some minor oversights may remain. Listeners are advised to consult the cited research papers directly for comprehensive details. Full references for all discussed research are provided for further exploration. Subscribe to the AI Frontiers channel for weekly deep dives into the latest advancements in artificial intelligence research. Stay informed on emerging breakthroughs, technological trends, and expert insights. This channel, AI Frontiers, is your consistent window into the evolving world of machine intelligence. Thank you for joining us as we explore the frontier of AI together. In this podcast, we bring you the latest breakthroughs in computer science and AI. Straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.